Good day to my fellow students. Welcome back to Mr. Lee's physics class. Today, we'll go to a new chapter of Sem 3 for Form 6 STPM Physics. So, for this chapter, we will learn about the wave optics. For the first subtopic of this wave topics, we'll go to the Huygens Principle. Ladies and gentlemen, the aim of the study is to study the Huygens Principle. So the objectives are to understand the Huygens Principle, to use the Huygens Principle to explain the diffraction and the interference. Next objective is the concept, to understand the concept of the coherence and the condition for the coherence light and source. Assume prior knowledge. Students should be familiar with 2-dimension and 3-dimension of wave. Students also should be familiar with the meaning of wave fronts. And finally, students should be familiar with phase difference between the two waves. Okay, let's go through the first slide. So please, let's observe the water droplets that drop into the swimming pool or drop onto the surface of the water. So from here, we can notice that a series of wave fronts is formed on the surface of the water. So now let's go to the next. In this lesson, you will learn to understand the Huygens Principle. To use the Huygens Principle to explain the difference and the diffraction and the interference. Students will also learn the concept of coherence for coherence light source. Huygens Principle. Huygens states that for every point on a wave front can be considered as a source of secondary spherical wavelet which spread out in the forward direction at the speed of the wave itself. The new wave front is the tangential surface to all of these secondary wavelets. Let's look at the Huygens Principle. First, points on the existing wavefronts become source of wavelets. Next, step 2, spherical wavelets spread out from each choose source. In time t, each of the wavelet would have traveled a distance of s equal to vt. S equal to the speed of the wave times with the time taken for the wave to travel. Next, the new wavefront is the common tangent to this wavelet. Meanwhile, it will be another line. Step 4, the process is repeated, so the direction of the propagation of the source is still in the same direction. The repeating of the same wave, called that is the Huygens Principle. Again, we look at the Huygens Principle. For step 1, point on the existing wavefronts becomes source of wavelet. And next, the spherical wavelet spread out from each chosen source. That means in the time t, each of the wavelet would have traveled a distance s equal to vt. Then next, the new wavelet is the common tension to this wavelet, and the process is repeated, okay, to get the infinity or to get the more wave of the wave with the same properties. This means that these are the two examples of the Huygens principle for a plane wave and also the circular wavelet. Summary. Huygens principle. Excuse me. Huygens principle can be stated as follows. Every point on the wavelet can be considered as a source of secondary spherical wavelets, which spread out in the forward direction at the speed of the wave itself. The new wavelet is the tangential surface to all of these secondary wavelets. Next, let's look at the direction at a barrier. The direction of the wave as a barrier, so means the wave will bend. This bending of the wavelets is due to the deflection of the wave. So show the construction. How the wave repeated and produced. Deflection at the aperture. Aperture means that is the the obstacle in front. So this means that if there are two obstacles to form a slit or form a aperture, this means this can be a narrow slit, wide slit, or the moderate slit. Narrow slit means the size of the aperture, the size of the slit is smaller than the wavelength, smaller than the wavelength, smaller than the lambda of the wave. So we said that it's narrow slit. Okay, for wide slit means the size of the slit, the size of the aperture A is longer than the wavelength. If the size of the aperture A is almost equal to the wavelength, we said that there is a moderate slit, moderate size of the slit. Let's look at the narrow slit. As we learned before in Form 5, Chapter 1 for the wave, so in the subtopic of diffraction, when a plane wave passes through a narrow slit, it will form a circular wavelet where the wavelength are equal, speed are equal, the properties of the wavelength are equal. Just the difference is the amplitude difference. The amplitude of the deflection, the amplitude of the wave after deflection is lower, where the energy of the wave also considered lower. For the Huygens construction, we notice that the wave pass through and it will become repeat the wave produce, and this we call that is the Huygens principle. For the wide slit, how is the Huygens construction? Okay, still the same thing is produced due to the interference phenomena. Ladies and gentlemen, the direction with barrier in the middle. So look at the wave. When the wave hit the obstacle, the wave will bend, and this is the another phenomena of the diffraction. Okay. When the interference produced. So if for the single slit, we notice that their diffractions are produced and produce the from the when the plane wave pass through a narrow slit, so the wave become circular. And if there's another, when the plane wave pass through the double slit, the wave will superimpose each other. When the two coherent wave means that the wave with the same amplitude, same frequency, same speed, and they are either in phase or with the same phase difference. So the interference will occur because of the phenomena of the two coherent sources superimpose each other. Superimpose means that they combine each other. Okay. Summary: the bending of wave when they pass by a barrier or the splitting of wave when they pass through an opening is called a diffraction. And when a wave passes through a two slit, the wave lines that emerge from the two slit from an interference pattern. So next, let's look at the wave A and B. We have two waves. What happened to the two waves with the same frequency? If they are with the same frequency but with a phase difference. Okay, when the wave with the phase difference, we notice that the amplitude, let's say the amplitude is 1 unit. Okay, this one unit, it will not form 2 unit, but more than 1 unit because they are in the same with a phase difference. What will happen if the frequency slightly increase for the frequency A? Okay, sorry. So we notice that the wave produced, the resultant wave produced will change the pattern. If I increase again, okay, cannot increase. If I reduce another wave, so this will be the wave pattern produced. And reduce, or if I increase to both with the same frequency, but slightly phase difference. Okay. So this resultant wave produced is due to the phenomena of the interference. Let's look at the two bulbs. If the two heat filaments bulb with light on switch on together, they produce the light simultaneously. Can we say that both of the light produced are coherent? The answer is no. Okay, why? Because we notice that for the two coherent source must have the two coherent source produced must have the same frequency in phase or in phase difference. They must have that means that the two waves exactly must from the same source. But due to the heat filament produced, the light produced is white color. Meanwhile, it's the combination of the 7 basic color. So different color of light with different wavelength. Meanwhile, a white light not suitable as a coherent source because inside the white light, the light with white color actually is formed by the seven basic color, seven color with different wavelength. So ladies and gentlemen, we cannot say that white light is a coherent source. Okay, except we use filter to filter the color. If both of them are red color, yes, they are in coherence. But the best way is the same color produced by the same source. Meanwhile, we can use one bulb, let the bulb pass through a single slit. After that, pass through a second slit. That means that the source produced, the both source produced as the double slit, consider is a coherent source because they are from the same source. Ladies and gentlemen, two sources of wave are coherent if the wave have the same phase difference at all times. And it follows the two sources must have the same frequency, same wave, same phase, and also same phase difference. Okay, and also can be same phase difference, constant phase difference. Ladies and gentlemen, as a conclusion for today's lesson, Huygens principle can be stated as follows. Every point on a wavefront can be considered as a source of secondary spherical wavelet which spread out in the forward direction at the speed of the wave itself. The new wavefront is the tangential surface to all of these secondary wavelets. The bending of wave when they pass by a barrier or the spreading of wave when they pass through an opening is called diffraction. When a wave passes through two slits, the wavefronts that emerge from the two slits form an interference pattern. Next, two sources of wave are coherent if the wave have the same phase difference at all times. And it follows that the two sources must have the same frequency. Ladies and gentlemen, this is the lesson for today. And now let's go to the question. Ladies and gentlemen, now let's go to the lesson. The question for the lesson. For the lesson, Huygens Principle, question 1 and question 2. And also the question 3. Next, we will go to the question number 4. And also question number 5. Next will be the suggested answer for the question. Question number 1, the answer is C. Question number 2, the answer is B. Then this is the answer for the question number 3. Question number 4. And also the answer, suggested answer for the question number 5. Okay, that's all, ladies and gentlemen. This is the lesson for today. So hope you enjoy my lesson and solve all the question. Thank you very much, and we continue again on the next lesson. See you. Bye bye.